Our planet spins every 24 hours, creating the cycle of day and night that shapes all life on Earth. This rotation sets the pace for our sleep, work, and play. But imagine if this spin suddenly slowed down by 10%. It might sound small, almost unnoticeable at first, but the effects would ripple through every aspect of life, from weather to ocean currents, and even how we perceive time itself. How would life adjust if days became noticeably longer? At the equator, the Earth's surface moves faster than anywhere else, traveling over 1,000 miles per hour. A slowdown here reduces the centrifugal force that slightly counteracts gravity. Though subtle, this shift would affect everything: how heavy we feel, how water distributes across the planet, and even the patterns of wind and storms. The faster the spin, the more energy flows through our planet. Imagine all of that energy slowing down, changing the rhythm of the world. Picture yourself waking up one morning, checking the clock, and realizing that your day feels longer, almost stretched. The 24-hour day you knew has been subtly extended. Sunlight lingers, shadows move differently, and the world seems to take its time. Every routine feels slightly off, and even simple activities like commuting or eating feel like they take longer. It's as if time itself has been gently pulled apart. Days would extend and nights would last longer. Imagine the sun rising slowly in the morning, lingering in the sky as if reluctant to set. Nighttime stretches as well, bringing longer hours of darkness for nocturnal animals and longer sleeping hours for humans. This change wouldn't happen overnight. It would be gradual but noticeable, subtly altering every living rhythm on the planet. The slower spin reduces the centrifugal force that gently pushes objects outward at the equator. Normally, this outward push slightly counteracts gravity. With the slowdown, this force weakens, making us feel just a tiny bit heavier. Oceans, too, respond. The water slightly redistributes itself, subtly changing tides and the shapes of coastlines. A seemingly small effect with far-reaching consequences. Standing at the equator, you might notice a subtle difference in your weight. Gravity would slightly outweigh the outward centrifugal force you're used to. While it wouldn't knock you over, this tiny change affects everything from ocean bulges to tectonic stress, and even the behavior of Earth's atmosphere. Our planet's delicate balance relies on its spin, and even minor adjustments ripple through countless systems. Earth's atmosphere is deeply tied to rotation. The slower the spin, the more the jet streams shift, altering wind patterns around the globe. This could change rainfall, storm formation, and temperature distributions. Regions that once enjoyed steady climates might see new extremes, and weather systems would dance to a different rhythm than we're accustomed to. Imagine the skies behaving unpredictably just because the Earth's rotation slowed. Storms would change course and intensity. Hurricanes, for example, rely on wind patterns shaped by the planet's rotation. With slower spin, these storms could take unusual paths, hit areas less prepared, or become more intense in unexpected locations. Even familiar weather phenomena could become unpredictable, challenging humans and ecosystems alike to adapt quickly. Longer days mean more sunlight reaching the surface. In some regions, extended exposure to the sun could lead to heat waves more intense than before. Imagine the sun lingering high in the sky for hours longer than usual, heating cities and farmlands. Our environment would respond: plants growing faster, water evaporating differently, and animals adjusting their routines to cope with the extended warmth. Conversely, longer nights would allow temperatures to drop further, especially in colder regions. Frost might form earlier in the evening and linger longer into the morning. Nighttime becomes more significant for ecosystems, giving nocturnal animals extra hours to hunt or forage. Humans might notice the chill, adjusting their routines, clothing, and energy usage accordingly. Nature's daily rhythm is subtly but profoundly altered. Tides are directly tied to Earth's rotation. As the day lengthens, tidal cycles stretch as well from the usual 24-hour rhythm to an extended 26.4 hours. This shift affects marine life, fishing schedules, and coastal ecosystems. Imagine the high tide arriving later, water levels remaining higher for longer, and entire shorelines experiencing a new rhythm. For sea creatures and humans alike, life must adapt to the slower beat of the ocean. Longer, higher tides could have practical consequences for coastal cities. Flooding may become more frequent or prolonged, especially during storms. Infrastructure designed for a 24-hour tidal cycle might need adjustment. Residents would notice subtle differences in daily life, from extended morning tides to delayed evening ebbs, reshaping the way communities interact with the sea. Major ocean currents, like the Gulf Stream, rely on Earth's rotation. Slower spin could weaken these currents, redistributing heat around the globe differently. Regions that once enjoyed mild climates might experience extremes: warmer summers, colder winters, or unexpected storms. Life in the oceans and on land would slowly adjust to these new flows of energy and water. Marine animals track tides and currents carefully. Fish, whales, and seabirds rely on these cycles for feeding, migration, and reproduction. As tidal rhythms stretch, species must adapt. Predators might need to hunt at different times, prey may appear at unexpected hours, and ecosystems could shift in surprising ways, all because of the subtle slowing of Earth's rotation. Even the solid Earth feels the change. Slower rotation slightly reduces the equatorial bulge, affecting stress along tectonic plates. While these effects are subtle, they can influence earthquake frequency and volcanic activity over long time scales. The planet's structure, seemingly static, is in constant dialogue with its spinning motion. Imagine standing in a familiar city when minor quakes start occurring slightly more often. Buildings sway gently, and people take notice, not because anything catastrophic is happening, but because the Earth itself is subtly adjusting to its new rotational rhythm. Life continues, but with a slightly altered beat. Volcanoes might respond to shifting stress beneath the surface. Magma flows could adjust, leading to minor changes in eruption patterns or frequency. It's a reminder that even the most massive structures on Earth are sensitive to the planet's spin and the delicate balance it maintains. Visualizing the Earth's interior, the equatorial bulge is slightly flattened by slower rotation. This tiny shift affects gravity distribution, ocean shapes, and even wind patterns. Though invisible to the naked eye, its consequences ripple across the planet, showing how interconnected every part of Earth truly is. Water flows respond to rotation, too. Sea levels subtly rise in some areas and fall in others. Coastal cities may notice the difference over years, and ecosystems that depend on specific water levels could adjust their behavior. Even a slight change in rotation sets off a chain reaction across the oceans. Longer tidal cycles mean more time for waves to act on shores. Beaches and cliffs erode at slightly different rates, reshaping coastlines over decades. Humans and wildlife alike must respond to these slow but steady changes in the environment. Birds and other migratory species rely on daylight cues. Longer days shift their migration, feeding, and nesting schedules. Our stickman friends might notice birds lingering in the sky, flying in new patterns, or adjusting to the extended daylight, illustrating the far-reaching effects of a slower spinning Earth. Nocturnal creatures gain longer nights to hunt, explore, and play. Owls, foxes, and raccoons benefit from extended hours of darkness, while humans see more activity in nature at night. Life adapts, following the new rhythm set by the planet itself. Plants respond directly to sunlight. Extended days accelerate photosynthesis in some crops, while others may experience stress from prolonged exposure. Farmers would notice changes in growth cycles, harvest times, and productivity, all because the day itself has grown longer. Imagine walking through fields where crops are ripening differently than usual. Farmers must adjust irrigation, planting schedules, and harvesting to keep up with these shifts. The world of agriculture, closely tied to Earth's rotation, becomes a living laboratory of adaptation. Even microscopic organisms respond to longer daylight. Photosynthesis, the process powering nearly all life, stretches in duration. Plants, algae, and plankton adjust, subtly changing energy flow through ecosystems worldwide. Human routines shift too. Clocks, work schedules, and schools might need adjustments. People experience longer days and social rhythms. Commuting, meal time, sleep slowly adapt to the expanded daylight hours. Financial markets must also adjust. Trading hours lengthen, clocks shift, and stock exchanges worldwide recalibrate. Our stickman traders watch in surprise as familiar routines stretch along with the day, reminding us that even abstract human systems respond to Earth's physical changes. Airlines adjust flight schedules as winds and daylight shift. Flight paths may change to optimize fuel efficiency and safety, showing that even high above Earth, a slower rotation has ripple effects. Satellites depend on precise timing. Slower rotation forces engineers to recalibrate systems that guide navigation, communication, and even weather monitoring. Technology and nature remain intertwined. Imagine a team of engineers monitoring satellite feeds, adjusting orbits, and timing to ensure GPS accuracy. Even subtle changes on a planetary scale require careful human oversight. From space, Earth spins more slowly. The familiar blur of rotation becomes more noticeable, the slow dance of day and night stretching across the globe. It's a subtle but striking change for anyone observing our planet from afar. Over months and years, the day gradually extends from our familiar 24 hours to over 26.4. Every system, biological, atmospheric, and human, adapts to the longer rhythm. Climate models show that slower rotation could intensify heat extremes and cold spells. Areas once predictable might experience new weather patterns, challenging humans, animals, and ecosystems alike. Half of the planet basks in extended sunlight while the other half endures longer nights. Shadows stretch, temperatures shift, and life continues to adapt to this new cycle of illumination. Storms might intensify or shift paths unpredictably. The slower spin of Earth subtly rearranges weather patterns, reminding us how delicate and interconnected our planet's systems truly are. Over time, the planet might settle into a new, slower rhythm. Life adapts, ecosystems find new balances, and humans continue their daily routines adjusted to the lengthened day. Humans, too, notice these changes. Sleep, work, and recreation all adjust as the day stretches. Even our perception of time subtly shifts, aligning with Earth's slower heartbeat. Science helps us understand these changes. Classrooms, labs, and museums show how rotation, gravity, and tides all intertwine, offering insight into the delicate balance of our planet. Satellites continue to monitor the planet, tracking changes in rotation, tides, weather, and ecosystems. These instruments provide data to help us adapt and plan for the subtle shifts caused by a slower spinning Earth. In the end, life adapts. Earth keeps spinning, just a little more slowly, and all living things from humans to nocturnal creatures adjust to the new rhythm. It's a gentle reminder of our planet's intricate, delicate dance in the cosmos.